Welcome to today's lesson. This is section 9.3, more hypothesis tests, but this time we're comparing two means. We are not going to do two proportions, although that is in the textbook, but we're going to look at two dependent means. We're still going to go through the same 6 steps, although for me step 6 is a little different, but it's still an interpretation. You still need to know your formula for the test statistic. It is very similar to the one that we did for 8.3 for means. Instead of x bar, it's now d bar. Instead of mu, it's now mu d. Instead of s, it's now sd. And we still divide by the square root of n. Because we're dealing with means, even though there's 2, we're still going to use the t.dist command, and we'll still use the complement rule if it's on the right-hand side. We'll still double if it's 2 tails. So let's look at the example. This data set, by the way, has already been typed in and you can obtain it on Blackboard, so please don't try to write it down. This is still definitely a hypothesis test question, which I still call a chapter 8, even though technically this is chapter 9. But still a hypothesis test question because it talks about the significance level. So we're going to go through those steps of a hypothesis test. Step 1 is also a little bit different. Because there are 2 data sets, because we're comparing 2 means, I know for sure it's going to be mu d, the difference of means. What number are we going to compare it to? Frequently, as in this problem, there is not really a number to compare it to, and please don't use 0.1. The only place 0.1 should be used is as alpha, which is what you're comparing in step 5. Nowhere else does the alpha come into play. And there's no other number really given except for the data set. Usually when that happens, the number is 0, and we'll talk about why that is in a minute. I think it will make more sense. Now, to figure out how we're comparing it, we need to do an extra step, something you haven't done in any of the previous hypothesis tests. Sometimes this will be done for you, and sometimes you will have to do it. And that is to define mu d. It is a difference of means. Now, in this particular case, I'm going to define mu d to be the North Raleigh location's mean minus the downtown location's mean. Notice I'm using a capital D for downtown, not little d for difference. If you had chosen mu sub d minus mu sub n, that would be perfectly fine as well. And again, sometimes that will be provided to you, and you'll have to work with it the way they give it to you, and sometimes you'll get to choose. So if I do it north minus downtown, notice we're supposed to be testing that the North Raleigh location has more sales than downtown. Now, if it helps, and it does for me, I like to write this out. So the North Raleigh has more sales, which would mean that the downtown location has less sales. Now, more minus less is a positive number, and positive numbers are numbers that are greater than 0, and that's where the 0 comes from that we put in our hypotheses. And since it is greater than 0, that will go in the alternative because it doesn't have equality. And then the null will be less than or equal to, or again, our book will say equal to. So you have to do this extra part in step 1. Step 6 is a little different. Most of the rest of this will stay the same, but you do have those 2 random things that pop up. Step 2, to draw my picture. Since it's means, it's still the t-distribution. Since it is greater than, it's right-tailed. And I'll label it t because we're using the t-distribution. Now for my test statistic, we have that new formula that I'll rewrite. We're going to have to do some calculations here. Now, I've already typed this into Excel, and again, the Excel document was provided to you, so you don't have to redo it. You are going to create a new column titled the differences, and you're going to have to be specific about how you do this. we chose to do north minus downtown. So when I calculate this first difference, I'm going to select the north location's revenue minus the downtown's location's revenue. And I'm going to drag that down. It's okay if you get negative numbers. It's okay if you get positive numbers. Okay, whatever's going to happen is going to happen. So then D bar is the average of the differences. So it is the average of the difference column. And S sub D is the standard deviation, and this is a sample, of course, this wasn't every single night, of the difference column. So we have 181.86 for D bar, and as always, you should show your work. So you did the average command. And I've already forgotten the number, 181.86. And we had to calculate S sub D, which was stdev.s of the differences, or 356.19. One note that I'd like to make about these, your book is absolutely correct in how they tell you to find D bar, but there are two ways to find D bar. I would say the way that I just did is by far the most consistent and will be the most helpful. And I'm afraid if you try another way that my stat lab sometimes shows, you may end up with the wrong answer. So let me just encourage you to find the difference column and then do the average and the stdev.s commands. So we have 181.86 minus mu d is 0 from the hypotheses, divided by 356.19 over the square root of, we had 7 data points. Be careful that note that n is 7 because there were 7 pairs of data points. There were technically 14 numbers, but that was not 14 data points. That was 7 pairs of data points. So we'll plug this into Excel. We will have to cell reference. So this is finding my standardized test statistic. And we get 1.35. So my p-value, notice this one is not two-tailed, so we don't need to multiply by 2, but it is on the right, so we need to use the complement rule. So we'll have 1 minus t dot dist of 1.35, comma, degrees of freedom is 6, comma, true. Or 0.1127. And our level of significance was 0.1. So this is a little bit bigger, but it's bigger, so we should fail to reject the null. And then your interpretation, I mentioned earlier I like man on the street interpretation, something that basically anybody will understand. We're still going to start with that significance level, which I know the man on the street wouldn't understand. But I don't think the man on the street would understand about differences of means. I think that would be a little too much. So I try to go back to the original thing. We were testing that North Raleigh has more sales than downtown, and we said that no, we don't think so. So we conclude that North Raleigh location has the opposite of more sales would be at most as much and then for our interpretation of the claim was that North Raleigh had more sales. And we failed to reject. Since we failed to reject, we should sound wishy-washy, but this time we're not saying it could be true. Going back to that table, when the alternative is the claim and we fail to reject the null, we say there is not enough evidence to support the claim. So again, slightly different in the interpretation. You definitely have some extra work to go in the hypotheses, but most of the rest of this should be pretty similar to what you saw in Chapter 8. And as always, if you have questions, please contact your instructor.